we are in Natural Bridges National Monument in southern Utah. As you can see in here behind me, we've had we call it pour-off. Rained all night last night, and in this normally dry environment, you can see that water plays a major role in these desert landscapes. Flowing water combined with weathering processes has produced the magnificent Kachina Bridge here in Natural Bridges National Monument. The older Owachimo Bridge has been exposed to weathering longer than Kachina and is now in a very delicate state. Flowing water in desert environments creates both erosional and depositional landforms. Erosional landforms, like natural bridges and arches, are spectacular, but they are rare in desert environments. An excellent location to observe the power of flowing water is the outstanding desert environment of Death Valley, California. Very common and pervasive depositional landforms in deserts are alluvial fans and bajadas. Alluvial fans and bajadas form from sediment carried down in gullies and streams from the adjacent mountain ranges. Flowing water also works to erode these alluvial fans into a series of gullies and can sometimes evolve into large incised dry stream beds. I'm standing down inside one of these incised alluvial fans, and if you look just behind me here, look at the wall that it's cut. This is the bank that the fluvial flowing water has cut. So again, just to point out that the vast majority of landform development inside this particular desert area is from running water. It's ironic because this has got the lowest amount of annual precipitation of any location in the United States. Its average annual precipitation is somewhere between 1 and 3 inches per year, which is 25 to 75 millimeters, or 2.5 centimeters and a little more than that. So running water is still producing the vast majority of the landforms here. We're on the floor of Death Valley, and looking at a desert floor, we have different types. Here in Death Valley, what we've got on the floor of the valley, pick out a good one here, is we have a lot of rock. You can see it's fairly sharp, fairly angular. There's a little bit of rounding, meaning it's been transported a short ways by water. But this entire valley floor is nothing but these alluvial fans and bajadas bringing the material down from the mountains and then distributing it out along the valley floor. So again, you see large pieces like this. You see angular pieces like this, and that tells us that this material has not traveled very far from its source, in this case, just the Funeral Mountains up behind us here. So when you think about how material is transported in desert processes, we take a look at gravity, then running water or fluvial, and then aeolian or windblown. And here in Death Valley desert here, we do have all three processes at work. Now what you're seeing right here, if you take a look down in here, I'm standing on what's called a playa. This is where water or snowmelt comes out of the mountains, flows through gravity, but it's a fluvial process, transports large materials, boulders, gravel, sand, and mud. And down here on the very bottom of the valley floor, this is the ultimate destination of that water. And what will happen is it will form initially what we call an ephemeral lake. So there'll be times when there'll be a bit of water here at the surface. Once that water evaporates and dries out, it becomes a playa. And that's what you see here. You're looking at mud cracks and that sort of thing. So this is a playa that we're on right now. Here I am standing in Badwater Basin. This is the lowest point in North America at 282 feet below sea level. Now you can look, it also has a very unusual surface. What you see is this polygonal pattern of salt that's coming up from the groundwater. As you can see in behind me, there's some very high mountains, and these mountains go up to 11,000 feet. So there's quite a bit of vertical relief here. But there's snow and rainfall in those mountains that works its way down into the valley bottom as groundwater. And that groundwater then comes back up to the surface full of salt in solution. And as it reaches the surface, it then precipitates out into these salt crystals, forming this very unusual polygonal pattern. One type of desert landform in the U.S. Southwest is a legacy of past climate. Extensive areas of the U.S. Southwest were covered by large pluvial lakes approximately 20,000 years ago and into the Holocene. This was due to the colder and wetter climate produced by the proximity of the Laurentide and Cordilleran ice sheets during the Wisconsin glaciation. This particular area of Death Valley was covered by Pluvial Lake Manly. What we see today is the ancient lake bed deposited by Lake Manly. The deposits left behind include significant amounts of salt in the form of halite crystals seen here in a location of Death Valley named the Devil's Golf Course. The rather bizarre shapes of the halite crystals are the result of ongoing weathering. To sum up, desert landforms produced by fluvial processes can be classified as either erosional or depositional. Erosional landforms include natural bridges, and these are produced by a combination of flowing water and weathering. Arroyos, gullies, and incised streams. Depositional landforms include alluvial fans and bajadas, salt pans, playas, ephemeral lakes, and finally, pluvial lake deposits. Many think of deserts as vast areas of wind-deposited sand and sand dunes, like the beautiful and surreal landscape of White Sands, New Mexico. However, the reality is wind-blown sand only occupies approximately 20% of the surface of tropical and subtropical deserts. It is water, a powerful agent of erosion and deposition, that has created most of our desert landforms.